All right, let's take a look at what this says. I'm going to say 13. All right, so I've got the current revision for the due date to be Saturday at the end of the day for this assignment. Oh, were you afraid it was going to be due tomorrow? No.
I thought so, yeah.
Yeah, so I just never updated that. I think that should give plenty of time. That lets, oh, and it's only Monday. Man, that should give us really a lot of time. Yeah, so that lets me talk today. I can take questions on Wednesday. I need to see what I did last year if there's any additional stuff, but I have a feeling that probably Wednesday and Friday are going to be dedicated to me providing tech support, so to speak, to all of you on this. All right. So what I wanted to talk about then was this class for testing that I have attached. It's a directory here. So there's some of that. Let me get a copy of the stack. I think I have that. And I should have come prepared. Let me see if I'm able to. I'm going to be able to do this quickly. Oops. Search for stack : replace with stack : or rather less than. Thank you. And then this will be type. That will be type. This will be type. Let's just search for int at this point. Whoops. Int. That's type. That's type. That's fine. That's type. That's it. Let's see. Did I mess it up somewhere? Well, we'll find out pretty quick. So let's say stack trial. And include stack.h. I'll create a stack of floats. that's going to work. Blast. That. $51. $51. Getting closer. Oh, I missed one. What line is that? 24? Here we go. We're in business. Class dismissed. All right. So we have this. Yes.
Can you go back 1 second to the class declaration?
We good? Let me go ahead, and what I should probably do is run 2 panes here. Oops. So we've got this nausea object, and what I'll do is I will create a stack of nausea objects. And my motivation for going through all this is to give you some idea of the strategy you use to take advantage of this nausea object to figure out what your stack is doing and problems it may have. So I need to include nausea.h, and that's probably sufficient to compile it. Just do a courtesy compile. Let me change this prompt. So I evidently have not completed my work here. It doesn't like undefined symbol. Wait. Yeah, that's that right there. Oh, of course. Where's my G++ line? Except handling dot. What have I done here? I somehow did a search and replace I didn't mean to do. All right, there we go. If I run this, so that's all the program does is I just create a stack and I'm done. I get a whole bunch of D's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 D's to be exact. And who can tell me where those 10, oh, actually I need to look at nausea class. So I look at nausea.h, it's got these were the three that I talked about: the default constructor, the copy constructor, and the assignment operator. These are the three functions that the stack class is going to invoke on whatever type is put inside here. So let me look at the source to that, and we can see that in the copy constructor, whenever the copy constructor is called, it's going to print a C. Whenever the default constructor is called, a D, and then A for the assignment operator. And looking at stack.h, and back to this code, this is invoking the stack's default constructor. So if I hunt down the stack's default constructor, which is right here, then where am I getting my default constructor called 10 times? Yep, that new statement. That's allocating space for 10 things, in this case 10 nausea objects, and it's running the default constructor for all of those. What is the next thing I wanted to do with that? All right, I just run with that. So we can do, I can create another nausea object, call it NO for nausea object, and then I can do fl.pushback, or I'm sorry, what am I doing with the stack? Is it just push?
Yes, push.
Okay, I can push it on there. Let me go ahead and compile again, run it. So now we get the same 10. Let me do this. Oops, this is going to standard error. All right, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the 10th one, 11th one. 10, 11. So the first 10 are corresponding to line 9 there, where those 10 are being allocated. The 11th one is line 10. And then we have a copy constructor and an assignment operator. And if I then look to investigate where that copy constructor and assignment operator are, and I look for the push function, now there's a lot of code that makes the eyes water just a little bit, but note that this if statement is only triggered once we reach around that 10th location there, right? So for the bulk of these uses of push, including this first use, we do not fall into this if statement. So I think it helps us in looking at this if I just go ahead and hide all that. So the if statement is going to be false. Basically all we have are lines 70 and 82. So where are our assignment and copy constructors being called? Yes?
The copy constructor is called when you pass in the argument to the function, and the assignment operator is called on line 82.
That's correct. 68, type is being passed in by value. That means element is a copy of NO. And so the copy constructor runs there. We increment an integer, the if statement's false, and then we do this assignment here, which is assigning that object to that particular item in the array. It's making sense? Now I need to pause and say that the compiler is really good at optimizing things, and I'm surprised it hasn't optimized things out yet, but just to prevent it from optimizing and making things harder on us, I have a little notes.txt here. Let's look at that just very quickly. The copy constructor is sometimes optimized out if there's no real work being done, and so add this to your compile line. I'll go ahead and add it for the duration of the period here to ensure that all the constructors are called. And that's just some boilerplate there in the bottom paragraph. All right, so no elide constructors. Let me just put that on my G++ line now, just so I don't forget that. No. Is it 2 dashes? F flag. The flag, no elide constructors. There we go. All right. And I shouldn't see any difference. Okay. So let's set up a scenario where we want this thing to crap out after the default constructor has been called 5 times. If we look at nausea.h, note I have an enumeration here, throw where, so you can say whether you want to throw an exception in the copy constructor, the default constructor, the assignment operator, or nowhere. And if we look at nausea.cpp, we'll see that nowhere is the default. So there's a right here, there is a variable called throw where. If I look at this right here, it's a static variable. Have we talked about static stuff in this class? Static variables? I mean, I know I've talked about it in 515, but in the 2 classes I get confused with each other. So I'll just give the 20-second statement that a static function or a static variable, static variables are easier to understand. A static member variable of a class is a variable that there is one of regardless of the number of objects. So that means if I create one nausea object, 1,000 nausea objects, or even if I never create a nausea object, there will be one throw where variable. The best way to look at line 9 is to think of it as a global variable. It's public, so it's a global variable that is specifically scoped to the nausea class, meaning that anywhere I can access a nausea object, I can access this variable. And so the only difference between accessing it and a global variable is I have to scope it. I have to say nausea : throw where. Okay, so that's useful when we look at our stack trial here. And I can go ahead and say that throw where, part of the nausea class, I want to assign to it the default constructor. That's where I want it to throw an exception. Okay, that's the purpose of that variable. Yes?
Why would you not use the dot operator? Colon in this case instead of dot.
The dot operator assumes an object. And I don't have an object. Now you can actually, if I create a nausea object, so let me bring this down here. Just syntax-wise, this should work. I believe that worked. Let's actually test it out. I'm sure it'll work, but now I'm in one of those weird modes where I don't think it'll work. Wait a minute, I may have other issues going on here. Because, so what I'm trying to do is use that scope, right? This isn't a global enumeration. This is an enumeration inside the nausea class. So let me say nausea. All right. Let me see what I'm doing wrong here. Expected unqualified ID. I thought I did qualify it. Yes.
You have to qualify it using the name of the enum2.
Well, that's what I'm wondering. I didn't think so. What did I do? Do I have documentation here? Oh, I have an example, don't I? I mean, I wrote the thing. I don't know what it does. Test nausea. Oh, I'm sorry. That's it. I was taking the type here, not the name of the variable. That's the type. I need type, not the type. I'm really happy for all the naming that I chose here. I think that's fine. Let's see. All right, there it goes. So then let me throw the, so the question was, whoops, let's see, type, nausea. Yeah, all right, I'm not going insane, that's fine. The reason this works is not because no, the nausea object has its own type variable. It's just simply the compiler ignores the fact that this is the NO object. It just turns out that that's sufficient information for the compiler to know that type is part of the nausea class. Okay. All right, so we set it up for the default constructor. The second thing we need to set up is when. And you'll note on line 10 on the left pane there is a second static integer called the trigger. So I want to assign a value to nausea's trigger, and I'm going to say that it is going to throw up, it's either on or, it must be on the 5th invocation of the default constructor. So let's compile it, clear the screen, run it, and we get 1, 2, 3, 4, 5, and it's right there on that 5th invocation that an exception is thrown. Yes?
Can you see the code, how it does that? How it...
Yeah, sure. It's actually quite simple. So whenever you enter the constructor, 100% of the time it will print that variable. So after it prints that variable, it basically says if the type is default constructor and I've reached my trigger point, I've had 5 invocations of it, then I'm going to throw this error. Throw this exception, I guess I should say. Yes.
Is there anywhere the trigger variable is being decremented? Or oh, inside that same line.
Yeah, I'm decrementing it right there.
Okay.
So why, if I've set my trigger to be the default constructor, why is trigger not decreasing on line 11 if I call a copy constructor? Right, then I'd get undesired behavior if I say called copy constructor 3 times and then it threw up on the second time I called the default constructor. Why? What code-wise is happening on any of these if statements such that trigger is only being decremented? Yes, in the right place.
You have short circuit of logical expressions.
That's right. It's short circuit logic, right? So we have Boolean expressions like this and means that both the left and right sides have to be true. If the left side is false, there's no need to look any further. We know that that if statement's going to be false, so the expression to the right-hand side of that AND operator is not evaluated if the value on the left side is false. It will not decrement because that's so that's what that's taking advantage of. Okay. In order to be able to examine whether things are going wrong, and I need to set up a scenario where it's more meaningful to look at this information, you really need to go into your stack template. And I mentioned this last time, you have to add some sort of debugging diagnostic output. So I'm going to add a print function. Throw that up here so I can see everything. All right, and what I want this print function to do is simply print out everything. Cout chunk size equals chunk size. I think I don't have, I'm going to have to include IO stream, and I'll say using standard cout standard endline. I'll do some copying and pasting. Chunk size maximum. What else do we have? Current size. I guess I don't really need chunk size since that's never going to change, but we put it in there for reference. Oops, this is current. And then this last one is base. And that'll print out an address. One thing that would be good debugging to help you is find any delete, and immediately after your delete, do that. That'll help you with finding bugs. All right, if you delete it, really, base is invalid at that point, so just make it 0. And if you reassign to it later, fine. So it isn't doing any harm. In fact, you can, put them on the same line to really emphasize that they're bound together. And there looks like there are only 3 places. So just do that, make your life a little easier in figuring this whole thing out. Yes?
What if we have a loop to print every element in the base in the print function? So that if
Right. So yes, the answer to your question. Let me rephrase your question. Is it all right to trick up print to do lots of cool things? Yes, absolutely. You do whatever you want with it. Just as long as you have some sort of diagnostic information coming from it. So let me go ahead and go into here and let me say, I can say fl dot print. I'll create a nausea object, I'll push it on there, and I'll say print again. Maybe if I'm going to have a bunch of these, maybe I'll do this like cout, and I'll do that, so that'll look a little nicer if we have multiple print statements. And in fact, given the way those, what I may do is, let me just put an end line to start with to make sure this thing's on its own line. We saw that there is no end line after those individual characters we're printing out, so that might ease the way things look. All right, let's try it. Let me actually, I don't remember how to switch the panes, so I do this. My keystroke sequence for switching the panes is to type really fast. There we go. All right. Yep. Well, I introduced bugs in my stack. Where's it complaining? Yep. All right. There we go. That was it. Oh, weird. Let me remove my trigger here. There. So we create the thing, we print it out, chunk size 10, maximum size 10, current size -1. We have some sort of address there, and then here's a DCA, so we had our 10 corresponding with line 15. There's the print. There's the D on line 17. The CA, the copy constructor and assignment operator, happens on line 18. Then I do another print, and we can see that our information has changed. Our current size is different, right? So let's try and introduce some issues here. I'm going to go ahead and add 6 objects. Add 6 objects to FL. And then let me create another object, stack nausea. Actually, what I'm going to do is I'm just going to put it right up there so they're next to each other. So I'm going to do a courtesy compile here just to see kind of what things are looking like. So up here we have a number of CAs, which is probably going to be 6 of those. Let's see, 10, L, yeah, 11, 12. That corresponds to all of our pushes, and otherwise things look great. Now let's take FL2, our new FL rather, and say, let me actually take these 2 lines. What I'm going to do is I'm just going to have 4 of them. So let me put a comment there, add 4 objects to new FL. And then what I want to do is I want to assign FL to new FL. Alright, because our stat class does have an assignment operator. I'll even put that in a note. Invoke stacks assignment operator. Come here. There shouldn't be any fireworks. Just a whole bunch of constructors and assignment operators being called as we do all this work. So let's try and I'm going to write that error output. So this is standard output, so we still see that information. Let's look at our output.text. 7, 8, 9, 10, 11, 12, 13, 14, 20. So that corresponds to the 2 default constructors on line 15 and 16. Then we create a nausea object. That's line 18. Now we have 6 pushes. So there's 1, let me see, I'm going to leave that off. That's 1, 2, 3, 4, 5, 6. And then we push 4 more onto the new FL. 1, 2, 3, 4. And now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. So tell me what is happening at the end there with, let me see, how do I want to do this? I think I want to So up to that point, that takes us through lines 20, 21, and 24, 25. Explain to me where my cursor is onto the end, how that corresponds to the assignment operator on line 27. So that's a simple assignment, assigning new FL to FL. Let me bring up stack.cpp. No, excuse me, stack.h. I normally would have made that an uppercase S. Oh well. Operator. There it is.
So it seems that when we're creating that new array of elements, we're invoking the default constructors for the maximum size, and then we're looping through the current size and assigning every single nausea in the old stack to the new one. Up until the current.
So give me line numbers on the left pane that correspond to what you're seeing on the right pane.
Line number 69 for the defaults.
All right, line 69, right? Maximum size is still 10. We can confirm that, but it is still 10. So that new statement on 69 gives us 10 of those, and then
the loop 75 and 76. Calls the assignment operator current size time.
Yes. Lines 75 and 76 are iterating through the current size. So that'll be 6 items. Recall that on the right-hand side of that expression, we'd added 6 items to that, so we have 6 assignments. So what I want, and now let me go back to this output, and we see, let me see, where's our prints? So we had a print after creating them, and we have a print. So let's move our prints. Let's print after we add 6 items there. Let's what's going to change is, we can actually just do this. Let's print new FL after we add a bunch of items to it, and now let's do the assignment where new FL gets changed on line 27, and then let's print it out again. Yeah? Let's see. And we can see that that's interesting, it actually reused the same memory. There we go. That's not guaranteed. So let me just, where's my a.out? Right there. All right, the creation of the stacks, the assignment of the 10 items, these 6, these 4. Then I print out our new FL, and it shows that indeed there are 4 items. That's its memory. Now we do the assignment. So the memory was deleted and reallocated with new, that's those, and then the loop with the 6 assignments. And now, again, we're looking at the same object, new FL, so after the assignment on line 27, FL's current size has changed from 4 items to 6 items, and also we can see that the memory allocated has changed. Yes?
So you're saying for the delete, you're talking about deleting from the old, where FL was, rather, and then...
Well, yeah, let me copy this line. Let me go back to stack.h and paste it. Oops, where's my operator? Here. So, right, so there, that line 80 there is what we have in the main program. So new FL is the invoking object, right? So when you, on line 67, say delete base, you're deleting new FL's base. And anything that's S dot, like line 68, you're taking new FL's maximum size and you're changing it to be FL's maximum size. And since, actually, I mean, if you really wanted to make it easy on the eyes, I could either go back to the main program and change all the FLs to be S, so that when you see S here, you immediately make a mental connection with S, or I suppose I could find everywhere that S is in this function and change it to FL. There, now. And I could, maybe I change new FL to be like this with an uppercase T. So there are all sorts of things you can do to make it easier to read. Yeah.
We have a print in the destructor. I'm asking because on line 67 we have the delete base. Would it go and call the destructor for every single element inside?
Yes, it's calling the destructor 10 times for this example on line 67. But although that would be, I suppose, of nominal interest, it's not a concern with this project because no one will ever, unless you're really, really naughty and want to be given a bad review at your job, you will never throw an exception in a destructor. So let's create a bug. Or I should say it's already buggy. Let's make it so that we see the bug. So what if an exception is thrown in this assignment operator here? Right? So first what I want to do is let me clear this and rerun. I've got to figure out where to do it. Now it's right here where we want to do it, right? This is that loop. So we just have to count where we need it to happen. So we know that we have 10 here because it was these 6 plus these 4. So that's going to be, that accounts for 10 of the assignments. So this has to be 11, 12, 13, 14, 15, 16. So let's say 11, 12, let's say 13. So now I'm going to come back to my test code and I'm going to set this up. I want it to bomb on the assignment. I don't recall if I spell it out or what, so let's look at nausea.h. Assignment op. Assignment op. And I wanted to do it on the 13th one. Oops, let me leave that up. Let me come here, let's compile, let's run. Now we have an issue, which is, well, here's our first print statement, which was on line 25, but I never hit line 29. Because an exception was thrown. So what you have to do in order to see what it looks like, right? Again, users of your stat class are going to do stuff just like this. Now I'm just creating a simple shell there. What I'm doing is catching the exception and then not doing anything because I'm debugging and I want to be able to inspect new FL to confirm that new FL is still ready to rock and roll if an unstable class throws an exception in my container. Yeah?
So by not doing anything, is that just pausing the program?
Here?
Yeah.
No, you're not pausing it. You're just capturing the exception and then dutifully ignoring it. Yes?
If I would say that in other words, the code we just paused or skipped is all the rest of the code in the assignment operator after. Just after the exception was thrown. So it flies out of the assignment operator.
It flies out in the middle of the assignment operator and then it continues with the application. So I don't want you to get confused with roles here. We're sitting in the role of the designer of the stat class, and we want to find where the stat class is going wrong. And the way we do that is we cause a naughty class, in this case nausea, to vomit forth at all sorts of different places, and then we inspect our stacks to make sure that they're still in good shape to be used. Because users of stack are going to expect that. Now, if we change roles, and now we're 10 years later using your stat class, the person using your stat class 10 years from now, let's do a global search and replace and search for nausea and replace it with Happy Fun Ball. So now this person's using your stack for their Happy Fun Ball, and they know that Happy Fun Ball may go south, so they've got some exception handling here. And then right here, they're going to clean up and then continue. Their assumption is when they hit line 33 that new FL is perfectly fine and can continue to be used, right? That's what we're preparing ourselves for. So let me get rid of that, go back to where we were. All right, so let's see what happens. Let's compile, let's run. And we can see that it did the 11th, 12th, 13th, and then it threw right there. Now, if something went wrong, new FL needs to be unchanged. And I've got the memory being reused. Let's see if I can get that scenario where it was changed. Yeah, it's not cooperating. It would change if I probably what would be better is if I pushed like a dozen objects on here. Let me go ahead and do that. I'm about out of time. No. Make it happen. I pushed 6 more on there. If I push 6 more on there, I have to change 13 to 19. All right, now this is gonna. No, I'm obviously missing something. Oh, that's because we had to allocate new memory, so there's going to be 10 more. That's going to be 29. There we go. Okay. So my new FL has 4 objects on it. If this thing throws up, my new FL needs 4 objects on it. Well, the maximum size is 20, and the current size is 11. I've got different memory. It's all screwed up. And I went pretty fast there at the end. Does everyone understand how I got up to 29 here? I pushed a dozen on here. What's our maximum size? It's 10, right? So as soon as I try to get that 11th item on, it's got to allocate a thing of 20 and copy them all over. And in that process of copying all over, I got a whole bunch more assignment operators. So I had to go ahead and add the correct number to get back to where we were. That looks like I'm off by 1. It looks like I have 4 there, and I need to subtract 1. It should be 28, I guess, instead of 29 to go after that 3rd one. But same difference, doesn't matter whether it's a 3rd or 4th one where it throws up. You can make it, let's see, so you can take it, let me copy this trial2.cpp, and in stack trial2, what I want to do is I want to throw it a slightly different location. So let me look at stack.h, and where I've been throwing is right here. What if instead I throw right here on this new allocation? Then, oh boy, I'd have to count. So since I'm out of time, I'm going to leave that. I'll actually delete this since I haven't changed it. Leave that as an exercise for you, but what you would have to do is count default constructors until you found where it was here. And if you did that right and threw somewhere in this statement, what you would find is base is equal to 0. So it's really screwed up then. It's not pointing to anything, right? So these are the kinds of things that you're troubleshooting for. Yes?
Would you be throwing a bad alloc in that case? C::: bad alloc.
Well, it depends what you mean by you. You as the stack designer are not going to throw any exceptions except to rethrow the users.
No, bad alloc.
No, if you're writing some application and you wanted to use the standard exceptions, I suppose you could throw bad alloc. But new has an invocation that'll throw an exception for you, so you don't have to do it yourself. Certainly in the context here, it's not your job to throw exceptions. It's your job to keep your class looking nice when other people throw exceptions.
Okay, so in that that last scenario, so you were saying that we did find that the stack was changed.
This one here?
Right.
Yeah.
Yeah. And at that point, that's when we would, from here, we would move on into figuring out how to handle it.
Right. So if you want, there are two places for, you have to basically identify everywhere in the function where an exception can be thrown. In this function, this assignment operator, it's two places. It's right here, that's because that's calling the default constructor of nausea, and the other place is right here because it's calling the assignment operator of nausea. So you have to make sure that if it throws up here or it throws up here in either of those situations, that line 34 and line 27 is printing the same output. Because new FL should be unchanged if something goes wrong in that assignment operator on line 30. That's the key. Now FL you don't have to worry about because FL doesn't change in line 30. It's only new FL that changes. Yes?
What if what would be an example if you, and what would you do if nausea threw an exception in the copy constructor?
Same rules apply. Just make if it depends where the copy constructor is being called.
See, yeah, passing in an argument to the function.
Yeah, and push.
Yeah.
Yeah.
And the copy constructor throws an exception.
Right.
In one of those pushes, what happens then?
You should be fine because if, like on line 25, if one of those pushes throws an exception, new FL will not have changed. Right? If I look here at the push function, I don't get beyond line 82, so nothing ever changes, and you're fine. That you don't have to do anything with that. There is one place, I will say there is one place, and it's the hardest one to find. There is one place in the stack class that calls a copy constructor that will screw up your stack, but it's not line 82. Yes?
One last quick question. In the stack class,
Uh-huh.
for the operator, public, you didn't put the template, I don't know what it's called, but the template, the type with the brackets in there. I know at the declaration.
Yeah, in this class declaration, you can get away without doing it.
Is it because the template type name applies to an enclosing scope of the stack class? Since it's already in the class scope, it doesn't have to read.
Right. Right. It's yes.
Okay. It doesn't have to, but it wouldn't harm it if it did or whatever. Because that was one thing I put in my templates.
You mean like this? kind of thing.
Yeah, I had that plus in the parameters as well.
Yeah, if you put it in, it doesn't hurt, but it's not necessary.
Okay.
All right, so I've definitely kept you a lot longer than 150. So go ahead and chew on this, and let's pick it up on Wednesday with questions that you have. Okay. And I'll get this stuff posted here. I'm not going to post it all. I'm just going to post, I guess, stack trial, right? Isn't that the only thing I really did? And you all have the template already, so I don't have to do that.
There's also the notes.txt.
Notes.txt is in the tarball. Oops, I should stop this one.